Solving systems of equations by graphing. Some terminology. A system of linear equations consists of two or more linear equations containing two or more variables. A solution of a system of linear equations is any ordered pair that makes all the equations true. Solutions of linear equations are also points that lie on the line. All solutions of linear equations can be found on its graph. A solution of two linear equations may have one solution, no solution, or infinitely many solutions. To solve systems of linear equations by graphing, it is helpful to write the equations in slope-intercept form. Example number 1, tell whether each ordered pair is a solution of the given system. Now please know we could do this with graph paper. We could graph both lines and see if those ordered pairs lie on the line. But here we don't have graph paper, so we will complete this problem algebraically. We'll start with the equation. We'll substitute x equals 1 and y equals 2 into that equation. And we'll see if we get a true statement by following order of operations. This one is true, therefore 1, 2 is a solution of the first equation. Now let's determine if it is a solution of the second equation. Again, substitute 1 in for x, 2 in for y. And complete the math and see if it's a true statement. Okay, so now we can tell that 1, 2, yes, is a solution of the system of equations. Now, earlier we determined that a system of equations either has no solution, one solution, or infinitely many. This might be the one solution, but let's determine if 2, 3 is also a solution. Substitute 2 in for x and 3 in for y. And let's complete the math. 12 does not equal 7. Therefore, 2, 3 is not a point that lies on the first line. So I really could stop right here and just say it's not a solution, but I will also show that it is not a solution to the second equation as well. So we can see that 2, 3 is not a solution of the system of equations. Therefore, the system that was given has one solution at 1, 2. All right, now let's use graphing to find the solution. We'll graph y equals x plus 3. The y-intercept is 3 and the slope is 1. Now let's graph the second line, whose y-intercept is 1. The slope is 2. I can see that that point right there is going to lie on both lines. The coordinates of that point, which I've made red, are 2, 5. Now let's prove algebraically why 2, 5 is the solution. It's a good idea to do this just to make sure that you graphed things correctly. We'll substitute 5 in place of y and 2 in place of x. We notice we get a true statement. Now let's also substitute 2, 5 into the second equation. We get another true statement. So we have proven why 2, 5 is the solution. So in this next example, the lines are not in slope-intercept form. So your teacher or your textbook might suggest that you write these lines in slope-intercept form. But I think because the lines are given in standard form, we can make a table of values using compatible numbers. So if I substitute 1 in place of x, can you see that y would equal 6? If I substitute 0 in place of y, x equals 3. And I can graph those 2 points and connect the points, and that's my line 3x plus y equals 9. And in the second equation, I can choose some convenient values for x and y also. If I substitute 0 in place of x, y would equal 4. if I put 1 in place of y, x would equal 6. I can graph those 2 points. And it looks to me on my graph like 2, 3 is going to be the solution. But again, sometimes with graphs, you have to be very precise, otherwise you could be misinterpreting the solution. I'm going to take these values for x and y, the 2 and the 3, and substitute them into the 2 equations to check that that is the solution. So yes, 2, 3 is the solution to the system of equations. Right, so in this example, it says to use a graphing calculator to solve the system. Now, most graphing calculators, you need to write your equations as y equals something. But if you check out Desmos.com, you can type both of these forms of the equations right into the app, the online website, and the calculator will graph them. So most of the time you're going to need to write them like this if you have your own graphing calculator, and then press graph, and you may have to adjust your window to see the solution. But again, with Desmos, the first line would be graphed this way, negative 2x minus 1. The second line would be graphed like that, negative 3x minus 5. And Desmos will come up with that when you just point in the general area of the intersection, it'll tell you that negative 3, 4 is the solution. And once again, we want to check that this is the solution. And I'll substitute negative 3 in for x and 4 in for y into the first equation. And I get a true statement. And I'll substitute these values into the second equation. I also get a true statement. So I did find the solution to that system of equations. All right, so now how about a word problem? Bo and Celine decide to rent bikes. There's 2 shops from which to choose. Rent-A-Bike charges $10 per hour per bike. We call that a flat rate. Bikerama charges only $4 per hour, but with a deposit of $15 per bike. At what number of hours will both shops charge the same amount, and what is that amount? So again, if I go to Desmos.com, I can graph these equations, but right now I don't have any equations. So let's pull out of the problem the important information. Rent-A-Bike. It is a flat rate. It's the $10 per hour, so that equation would be y equals 10x. It's proportional, right? So that graph would go through the origin and have a slope of 10. Now, Bikerama, the amount that's charged is going to be the rate, right, of $4, so it's a less steep slope, but it has a y-intercept of 15. All right, so now I will graph y equals 10x using Desmos, and you'd get an equation that looks like this. And then if I graph y equals 4x plus 15 on the same coordinate plane, I can see there is a solution way up top there. It's a little bit hard to read, but according to Desmos, 2.5, 25 is the solution of the system of equations. I would then just make sure that that makes sense using the algebra. And to interpret this, it's saying that at 2.5 hours, both shops charge the same amount of money, which would be $25. So finally, we've got a couple of practice problems for you to do. We want you to do practice problems A and B. So I'm going to ask you to put this on pause. I want you to try this yourself. This is related to the first problem we did. And tell whether the ordered pair is a solution of each given system. When you're ready, check that my solution matches what you have. Okay, so what we did was we substituted 1 in place of x and 3 in place of y. We got a true statement for the first equation. We'll do the same thing for the second. And yes, 1, 3 is a solution of the system of equations. In problem B, we learn that 3, 4 is not a solution of either equation. Therefore, it's not a solution of the system of equations. And finally, we'll let you do these two by yourself, and we'd like you to find the solution to the system of equations by graphing. And you can use your slope-intercept form, which has been given. In problem D, you can find some convenient values for x and y to graph that second line.